Hi, I'm Professor Goins. In this video, I'm going to take a look at the operation between functions known as composition. Start with the definition. The definition says the composition of f of x and g of x is given by the following. F composed with g, this little circle refers to the operation of composition. So f composed with g is given by f evaluated at g of x. Notice that the function that is listed on the right is used as an input for the function on the left. What we're going to do is we're going to take a look at how do we evaluate a composition, how do I simplify a composition, and then how do I take a function and decompose it into a composition. Okay, let's start with evaluating. For example, let's use the functions f of x equals x squared minus x, and g of x is equal to 3x plus 4. Part A, let's evaluate f composed with g of 1. F composed with g evaluated at 1. Okay. Well, if I look at the definition and I just write this symbolically, what this says is this will be f with input g, and then notice that whatever input is here goes inside of g. So this would be f of g of 1. Now what this tells me is that the number that I have inside the parentheses, the first thing I do with that is I plug it into the function g. I compute that function value. Then that function value becomes an input for f. Again, 1 is an input for the composition. The way this works is 1 gets plugged into g first. 1 is an input for g. I compute that function value to get an output. That output then becomes an input for the function f. Okay, so let's see how this works. 1 gets plugged into g. That would be 3 times 1 plus 4, which would be 7. So then what I would do is I would take 7 as my new input. Remember, g of 1 is equal to 7. Now I take 7 and I plug that into the function f, giving me 7 squared minus 7, which would be 49 minus 7, which would be, so 49 minus 7 gives me 42. Part B. Let's look at f composed with g of 0. Same format. This would be f evaluated at, the input for f would be g of 0. Alright? The number 0 gets plugged into g. G of 0. So now let's look at the g function. G of 0 would be 3 times 0 plus 4. 0 plus 4 would be 4, meaning 4 would now be the input for f. F with 4 would be 4 squared minus 4. 16 minus 4 would be 12. Okay? Part C. Now what if I was to take these and reverse them? In other words, I would put g first. Let's look at g of f of negative 3. Okay? This would be g evaluated at. So now remember I said that the function that's listed on the right gets plugged into the function on the left. So the order does matter here. What I have to do is this number negative 3 gets plugged into f first. I compute that function value. That function value now becomes your new input. All right, negative 3, that gets plugged into f. Let's write that out. Negative 3 gets plugged into f. Well, what does f do? F takes the input and it squares it, and then it subtracts the input. So inside of g, I'm going to have negative 3, make sure I square that whole thing, minus negative 3. Right, so I square negative 3 and then I subtract negative 3. Right? Inside of g, so the input of g now becomes negative 3 squared is positive 9, minus minus is plus. This would be 9 plus 3, which would be 12. Now 12 is the output for f, and it becomes an input for g. What does g do? G takes the input and it multiplies it by 3, and then it adds 4. That means I would have 3 times 12 plus 4. 3 times 12 would be 36. 36 plus 4 would be 40. Okay, so this is how you evaluate a composition. You plug the number into the function on the right, compute that function value. That function value then becomes an input for the function on the left. Okay, now how do we simplify a composition? Well, to simplify a composition, it's very, very similar to the examples we did over here. Notice in the definition I had an x that just plays the role for an arbitrary input. Here I put specific inputs. But what if instead of f of g of 1, if we did f of g of x? Then what would we do for, say, g of x? Well, instead of having a number, we'll have the function expression. So let's see how that works. And for illustration purposes, let's use those same functions. All right, next example. Once again, let's use f of x is x squared minus x, and g of x is 3x plus 4. Part A, let's look at what if I was to evaluate f of g of x. And we'll compare it with the previous example. All right, first and foremost, f evaluated it. Well, what's the input for f? What's the function that's to the right of it, meaning g, but this time I'm going to use x. This is then very similar to this, except there's a number here, and here there's a specific or an arbitrary, not specific, an arbitrary input, x. All right, over here, what did we do? Well, we found g of 1, that was 7, okay, because I took 1, plugged it into g, so I simplified that as much as possible. In other words, I went from the function name to the function expression. Let's do the same thing over here. G of x, well, if I go to the function expression, it's just going to be 3x plus 4. That means my new input is going to be 3x plus 4. Over here, my new input was a number. Here, my input is an expression. Both of those come from the function expression for g, whether it's if I can plug in a number and evaluate, or just use the expression itself. All right, what did we do with that 7? Well, this is familiar. To evaluate a function value, I just take this as my input, and I plug it into each input location. We'll do the same thing here. I'll take 3x plus 4, that's my input. Well, what does f do? It squares the input and then subtracts the input. That means I'm going to have 3x plus 4 squared minus 3x plus 4. Now what we could do is we could square that and then subtract those terms and combine like terms in the end. We might as well go ahead and do that. So if I square this, remember you have to FOIL it. That would give me a 3x times a 3x would be 9x squared. 3x and 4, so I'd have 12x. 4 and 3x, 12x. 4 and 4 plus 16. And then you'd have distribute minus or negative through here, negative 3x minus 4. And then you could combine like terms. 9x squared. Then how many x's do we have? Well, I've got 12, another 12 that'd make it 24, and then 24 minus 3 of them would give you a 21. Therefore, it's plus 21x. And then what are the constants? I would have a 16 minus 4, which would be 12. So that'd be plus 12. Now, what should happen is if I was to take, just to kind of check our work here, I could evaluate f of g of 1 two different ways. I could do it like I did over here in blue, where I take the number and I plug it into G, get that output, the 7, plug that 7 into F, compute 42. Or I could simplify the expression for f of G, and then to do f of G of 1, I could take 1 and plug it into this. So go ahead and check that out. If I take 1 and plug it into this, what do we get? Well, what's 9 times 1 squared would be 9, plus 21 times 1, so 9 and 21 would give you 30, and then 30 and 12 would be 42, and that matches what we have over here. All right, similarly for part B, let's reverse the order, and let's look at G of f of x. Notice this time my input for G is going to be the function f. That's going to give me G evaluated at f of x. Well, in part C over here, we did the same thing. I had G of f with a specific number. Here I've got G of f with an arbitrary input. All right, over here, what we did is -3 gets plugged into f of -3. Then we use this, we went to the function expression for f, right, over here. We computed that. So the next step came from the function expression for this function, right? And we got a specific number. That specific number then gets plugged into G. Well, over here I don't have a specific number. I just have f of x. Therefore, I'll use x squared minus x as my input. And over here I plugged in a specific number to G. Here I'm going to plug in an expression to G, but it's the same idea. All right, look what we did. We took that number 12, I plugged that into G, meaning it'd be 3 times 12 plus 4. Whereas over here, I'll take x squared minus x, plug that into G, meaning x squared minus x is going to go after the 3. 3 times the input, and then plus 4, and then simplify. Well, this simplification is easier than part A. It's just one step. Just distribute the 3. That would give me a 3x squared minus 3x plus 4. If I plug in a specific number, I should get a specific number as an output. Whereas here, if I take the composition of expressions, then chances are your end result will also be an expression. Okay. So there's the basic idea for evaluating and simplifying a composition. There's another technique or another type of an exercise that you might see in your textbook. If you're in a pre-calc class or an algebra class, more likely in a pre-calculus class, because it's something that you'll definitely need to understand when you take calculus. And there's no calculus here, but I want to show you how you can decompose a function into a composition. See, it's not erasing well. Let me see if this works better. That works a little better. So here's the setup. Suppose I give you the following function. H of x is equal to 4x to the third minus 5. Okay, so I've got this function. H of x is 4x to the third minus 5. And what I want to do is I want to find f of x and g of x, for which H is the composition of those two. Phrased differently, what two functions did I take the composition of to get H of x as a result? Okay. So let's go ahead and let's list f of x equals, and then g of x is equals. So what two functions did I take the composition of to get h of x as a result? All right, in other words, remember that g of x is what I'm plugging in. Well, we could say that g of x was x to the third. I see an x to the third here, so maybe I plugged in an x to the third. Let's just take a guess, and let's say g of x is x to the third. So then what did I plug x to the third into to get h of x as a result? Well, certainly there had to be a 4. Certainly we see there's a minus 5. And remember that the input g of x goes wherever x is, right? So I've got f of 3x plus 4. So that 3x plus 4 was my input. That went both here and here. Well, that means x cubed has to go into that one. If I take f of x is 4x minus 5 and g of x is x to the third, and I take the composition f composed with g, let's check it out. If I take the composition f composed with g, right, then g of x is x to the third, so this would be f of x to the third. And well, what does f do? F takes the input, x, multiplies by 4, and then subtracts 5. Therefore, I would take 4 times the input and subtract 5. And notice that, of course, this matches this. So this is one way that I could write that as a composition. It turns out that there's actually infinitely many ways I could do that. Let me just give you one other example, and you can kind of see why there would be more than one possibility. Let's say I chose f of x to be 2x minus 5. Then g of x could be 2x to the third. Because if I take 2x to the third and I plug it in here, I'd have 2 times 2x to the third, which would be 4x to the third. And so on and so forth. So you could come up with all sorts of different examples. All right, let's take a look at maybe one more example. And again, this will probably be the one that's a little bit more applicable to what you will see when you take your calculus course. Again, not that I'm going to describe any calculus in this video, but this is kind of the main one that you would take a look at. For example, let's say h of x is equal to the 4th root of x to the third plus 2x. So what I want to do, the same goal, same directions, right? Find f and g for which h is the composition of those two. So which functions I take the composition of to get this as a result. All right, I'm just going to put a blank f of x and g of x here. Fill those in, or think about what those would be. Give you a couple of seconds, or you could pause the video and think about it, and then I'll go ahead and fill it in. Okay. Remember, g of x is what I'm plugging in, f of x is what I'm plugging into. So what does it look like I plugged in? Well, probably the radicand is what I plugged in. So therefore, what I'll do is I'll assign g of x to be x to the third plus 2x. And what did I plug that into? Well, the 4th root of x. Okay, so this would be one way to decompose that into the composition of two functions. What did I plug in? What did I plug it into? Just like over here, there are lots of ways to actually find f and g. There's, just like over here, there's infinitely many, but we don't want to kind of get too bizarre with it. We want to just pick what expression is there, and I want to pick g of x to be just as the entire radicand, and f of x would be basically what's left over. And for some informal language that you're going to see here in again, your calculus course, we'll call this the inside function, and we'll call this the outside function.